Hello, this is a contribution from Kuzu Console to the PlatOn network. In this presentation, we are going to have a walkthrough or a guide through PlatOn's world-leading privacy-preserving computation abilities in the world today and how PlatOn aims at solving the current issues or problems the blockchain ecosystem is facing today, such as the issue of privacy, security, and storage management. So here are some important links relating to the PlatOn's privacy preserving white paper, the Twitter social media handle, and the PlatOn website. PlatOn is a privacy AI computing network that works on the blockchain to provide privacy to people's data on the blockchain network. So by combining blockchain and privacy computing technology together with AI, PlatOn is building a decentralized collaborative artificial intelligence network and global brain to promote the democratization of artificial intelligence and establish a secure general artificial intelligence in the world today. So to begin, let us take a look at some of the features of PlatOn. So we have AI empowerment, privacy protection, algorithm sharing, and hash power trading. So with AI empowerment, a smarter and more powerful AI model needs to be built through massive data. PlatOn helps the AI model establish a compliant data acquisition channel without infringing on data privacy. Privacy protection. Through the privacy computing technology based on cryptography, a new computing paradigm is provided, making data available and invisible so that data privacy can be fully protected. We also have algorithm sharing. The algorithm model that defines the calculation logic and data input and output format can be shared and traded between the demander and the provider on PlatOn. Lastly, we have the hash power trading. Through verifiable computing and blockchain technology, it provides a publishing platform for computing tasks with high computing power requirements and can verify the calculation results with minimum computing power to achieve peer-to-peer transactions of computing power. So we have seen how AI empowerment has helped with PlatOn building the model. We have the privacy protection using the cryptography method to make sure data is secure and private. We have algorithm sharing where data input and output formats can be shared or traded between the demander and the provider on PlatOn. And then also we have seen how it is being used for hash power trading through verifiable computing and blockchain technology. It provides a platform for computing tasks with high computing power requirements and can verify calculation results with minimum computing power to achieve peer-to-peer transactions for computing power. As we all know, some of the underlying major issues the blockchain ecosystem is facing in the world today is the issue of security, privacy, and storage management. Over the past 3 years of continuous changes and improvements, PlatOn has been able to achieve leading features in the blockchain ecosystem as well as complete architecture of its applications and overall excellent performance. One of the main features of the PlatOn network is a privacy-preserving computing technology which has been able to achieve thanks to its cryptographic foundation. PlatOn has been able to combat the three major challenges facing the blockchain ecosystem, which includes storage, privacy, and management issues. Storage is one of the issues that has been a major concern to the blockchain community. Just like the name blockchain implies, each block contains multiple information or transactions which are carefully chained to another cryptographic hash function. Because of the hash function, it is quite impossible to tamper with information or transactions stored on the blockchain. Unfortunately, as the number of transactions continue to grow, space and storage to solve this problem has become a major issue, And also with the increased data of blockchain in the blockchain, the price of the validator increases. The PlatON 2.0 version aims to provide a solution to the storage and management issue. The vision of this version is to build a decentralized and collaborative global artificial intelligence to drive the democratization of artificial intelligence on the blockchain network. In the PlatON 2.0 version, a three-layer network is considered. The first layer is the consensus layer. The consensus network is a decentralized network composing of blockchain nodes which are interconnected to each other through peer-to-peer protocols. With this, there will be no need for a validator. That is, one needs to be trusted by doing so. The management issue has been dealt with. While on the blockchain network, smart contracts can be executed automatically, not manually. The second layer of the PlatON version 2.0, which is the privacy preserving computation network, which will be discussed later on. The third layer is a collaborative artificial intelligence network in which multi-agent systems and artificial intelligence agents can operate independently. By doing so, less space will be occupied on the blockchain and it can finally form an autonomous AI network. Then we talk about data privacy, which is one of the key or core functions of PlatON and one of the key solutions PlatON aims at providing to the blockchain ecosystem is privacy. During the early stage of Bitcoin, individuals were able to maintain their network by saving copies of all their data. With this method, the consensus was achieved, but their transactions were made public, making it possible for other parties to have access to. Subsequently, developers now realize that privacy is one of the major issues affecting the blockchain ecosystem, which is what PlatON, coexisting together with artificial intelligence, aims at providing a solution to. In the second layer of the PlatON 2.0 version, a data privacy solution was provided. In this version, data nodes and computing nodes could connect to this layer and publish data and contribute computing power. Through smart contracts on the blockchain, a decentralized sharing and trading marketplace for data, algorithms, and computing power can be built. Based on cryptographic economics, which will form an effective incentive mechanism to motivate more data, algorithms, and computing power to join the network. Also, PlatON provides a secure multi-party computing algorithm which helps to keep data private with this feature. Healthcare sector, financial organizations, and other companies that have contracts, projects, or even applications built on the blockchain can use PlatON to keep their records private. Also, PlatON provides a computing paradigm that helps make data available but not visible through cryptography, so data privacy can be fully protected, all thanks to PlatON and artificial intelligence through its computation abilities. In the next slide, we are going to take a look at PlatON's solution algorithms, how it works, and what it is made up of. So when we take a look at some of the algorithms that PlatON uses to provide the solution to the issue of privacy, storage and management, and security in the blockchain ecosystem, we have the zero-knowledge succinct non-interactive argument of knowledge, primitives, and accumulators. As we all know, algorithms are step-by-step procedures for solving a particular problem or a set of instructions that lead into the solution of solving a problem. Most of the listed algorithms are based on elliptic curve cryptography. An elliptic cryptography is a public key encryption technique used to encrypt and secure data or transactions for privacy purposes. Let us take a look at some of the algorithms which was used to create the solution to the privacy and storage issues by the PlatON team. We have the zero knowledge token non-interactive argument of knowledge. This is a type of cryptographic technique which allows two parties to verify information with each other without sharing data or resources related to that topic. This algorithm is usually used to protect the anonymity and confidentiality of transactions by users. We have the primitives. These are well-established, low-level cryptographic algorithms that are used to build cryptographic security systems. It is mainly used to construct advanced algorithm and cryptographic solutions. Lastly, we have the accumulators. Accumulators can be defined as a one-way membership hash function which allows users to certify that potential candidates are a member of a certain set with a short and easy to verify witness. With the listed cryptographic algorithm, PlatON has been able to create a solution to the privacy problem, which is a big issue in the blockchain ecosystem. For the past 10 years, the blockchain community has grown big and fast. A lot of companies, government agencies, business owners, and individuals have taken a keen interest in the blockchain community. To secure the trust of these individuals, their records and transactions should be taken seriously. Each data of an individual on the blockchain network should be secured and made inaccessible to the public eyes. Also, a company on the blockchain should be able to perform transactions discreetly without the interference of a third party or a validator. The PlatOn team has worked so hard to achieve this. So as an individual or a company that wishes to implement a privacy-preserving policy, make use of the PlatOn network. We have seen the problems, the underlying problems the blockchain ecosystem is facing. We have also seen how PlatOn's AI computing capabilities for the privacy-preserving policy has provided. We have seen what that has provided, the solution that has provided together with the use of artificial intelligence, also known as AI, to solve the issue of privacy on the blockchain network or on the blockchain ecosystem. So with PlatOn, the issue of privacy has been solved on the blockchain ecosystem through its privacy-preserving computation abilities in the world today.